This is video 4 of Unit 9. In this video we're just going to do a bunch of examples of writing chemical equations, or writing the products of chemical equations. So we've got 5 reactions here, and remember we talked about the 5 reaction types: synthesis, decomposition, single replacement, double replacement, and combustion. And these 5 are all represented here. So before you can write the products of a reaction, you first have to try to guess, or not guess, but decide which of these 5 the reaction represents. Apologize. So in the first case, it looks like we're putting together 2 elements, and they're going to form something. The only thing they can form is a compound, which means this is a synthesis reaction. So because this is synthesis, this allows us to predict the products with more certainty. And really all that will happen is potassium will create a compound with oxygen. They will combine together. They will synthesize. So we're going to show a compound made of potassium and oxygen. Now, do we write Ko? Is it just a potassium for an oxygen? Well, because this is an ionic compound, potassium's a metal, oxygen's a nonmetal, we have to think about the charges, because remember, ionic compounds are made of ions, charges. So the charge of potassium, recall from the periodic table, is +1. The charge of oxygen is -2. And when we balance the two, we have to make sure the charges balance out, which means we need 2 potassiums for every 1 oxygen, which means there should be a 2 down here. You have to do this sort of thing with ionic compounds whenever you're writing products. And this is really important. In fact, you'll get the answer wrong unless you do this. So these are the products. Now, we also want to balance the equation. So we practiced balancing a few lessons ago. Let's do this quickly. Since we have 2 oxygens on the left, we need 2 on the right. We'll put a 2 in front. That gets us up to 4 potassiums, and we can put a 4 in front. And this balances for us the first equation. Okay, how about the second one? What type of reaction is this? Well, we have a compound and then an arrow. The only thing that can happen to this compound is it can break down into elements, which means this is a decomposition reaction. So knowing this is a decomposition reaction, we can now predict the products. And really what you're going to show is kind of the reverse of part A, where you see the products. These elements will be separated. So you'll have sodium, and then you want to put a plus to make sure they're separated, and you'll put chlorine. Now, chlorine actually is one of the 7 diatomic elements, because chlorine is diatomic. It's one of the 7 honcobriefs. We have to double chlorine up, which means chlorine will have a 2 at the bottom. Make sure you watch out for these. These include hydrogen, they include oxygen, nitrogen. Remember those 7. Let's also balance this equation, and it looks like we have 2 chlorines on the right, so we'll double this up. That puts us to 2 sodiums, double it up, and we are balanced. Okay, how about the next one? How about part C? Let's see if we can predict which of these 4 it is. And it is, we have a compound and a single element. So most likely it's going to be single replacement. Anytime you have a compound and an element, the element will replace a similar element in the compound. So calcium will come in, and calcium will replace the chromium. So if calcium replaces the chromium, chromium will become single. That's what we call the single replacement. So we have a compound of calcium and chlorine. So we have calcium and chlorine. And then we have chromium by itself. So we'll put plus chromium. Now, calcium and chlorine, again, is an ionic compound. And just like in part A, we had to balance the charges, we have to consider charges here. So since calcium has a +2 charge, chlorine has a -1 charge, we need 2 chlorines for every calcium, which means we will need a 2 down here. Again, this is very important. If you don't do that, you'll get the answer wrong. Let's go ahead and balance the whole equation now. Since we have 3 chlorines on the left, 2 chlorines on the right, let's make them both up to 6. So we'll put a 3 in here. That gives us 6 chlorines. We'll put a 2 in front of here, 6 chlorines. That gets us 2 chromiums. So we'll double this up. This gets us 3 calcium. We'll triple this up. And this is the balanced equation, and you can erase the little arrows if those are getting in the way. And you see the full balanced equation. The next one, part D, we have a compound on the left, we have a compound on the right. This will probably be double replacement. Notice they're lined up exactly in the order that they're given. And in double replacement, the metal, one cation, replaces another cation. So the metal will replace the metal, and this metal will replace this metal. So we have a double replacement going on. So on the products, we'll have barium teamed up with nitrate. We have silver teamed up with chlorine. So let's put barium and nitrate together first. Here we have BaNO3. You have to consider again, this is an ionic compound, you have to consider the charges. So the question is the same. What's the charge of barium? What's the charge of nitrate? Barium turns out to be +2, nitrate -1. We need 2 nitrates for every barium, which means we need to put parentheses around the nitrate and put a 2 down here. And the other compound will be when silver replaces barium, you get silver chloride. Now, again, silver chloride is an ionic compound. We have to think about the charges. We know that chlorine has a -1 charge. We know that silver, however, comes from the D block. So the question is, what is the charge of silver? Well, the charge of silver can be determined from the charge of silver on the left side. In double replacement reactions, the charges of the metals do not change. So because silver is teamed up with one nitrate on the left side, it has a +1 charge, which means it'll have a +1 charge on the right side, which means we only need 1 chlorine to balance it, and this is the correct compound. So let's go ahead and clean this up a little bit. Lastly, before we take off, we must balance the equation. So it looks like we have 2 chlorines on the right side, so we'll put a 2 in front of here. That gives us 2 silvers. We'll put a 2 in front of here. It gives us 2 nitrates, and in fact we have 2 nitrates. The equation is balanced. Incidentally, one of the ways to know that you've written the products correctly is if the equation balances. That's usually a good indication that you have written the compound correctly. Let's go ahead and try the last one here. And what do we have for the reaction type in the last one? Well, we have a hydrocarbon on the left with oxygen, and that is an indication of combustion. Anytime you have a hydrocarbon, a compound made from carbon and hydrogen, which is essentially a fuel, reacting with oxygen, you always will form carbon dioxide and water. This one is the easiest equation to write because you don't have to think about the products much. You don't have to balance any charges. It's really every single time you have CO2 and H2O. The only thing that will be left will be to balance the equation. So since we have 4 carbons on the left, we'll put 4 on the right. We have 8 hydrogens on the left. To make this into 8, we'll put a 4 in front of here. That gets us 4 oxygens plus another 4 times 2, 8. That gets us 12 oxygens. We'll put a 6 in front of here. And the equation is now balanced. So this was combustion. This was single replacement. And this was double replacement. Kind of ran into a little bit of a tight space. So hopefully these examples make sense. Now, this is difficult unless you try it yourself. So the next one is for you to practice. Go ahead and practice this one on your own. Practice example 8. Go ahead and take some time and run through this, and we will wrap this up in class.